firstly, let's look at how to prepare the CAD model for your workflow, or how to use SnapHex Mesh generally. The recommended workflow by using SnapHex Mesh is always starting from your CAD model, which means the design engineers or yourself should prepare the computer-aided design model, it's usually 3D dimensional, and you can construct the dimensions using any software tools you like, for example, FreeCAD or SolidWorks or Inventor or any other open source like Blender. And you really need to care about the domains, which means because you want to study the heat transfer between two domains, and that means you need to use this first domain as the air and the second domain as the water. And remember, for the air domains, you should exclude the water section, and of course for the water domain you only need the water as well. So this is a cross section of the top parts, and make sure you build them and let them to be in the same coordinate system, which means when you place them together, this should form the exact arrangement of your heat exchanger. Right here, as indicated, I have the X, Y. So this is my origin. So I have the positive direction along this of X, and the positive Y and Z direction. If you use the right hand rule, it will be point inward. So two domains prepared separately, and the CAD model built for each domain. And if you know any knowledge of the export of the software, so you can export as STL file. So if you use 3D printers before, the STL file is a very universal or mesh file that can be accepted by many applications. But remember, the STL file must be in ASCII format, which means a text format, and all the faces should be forming a closed cavity. So if you build it as a closed shape or as a solid, and when you export as a STL file, it's always forming a closed cavity. So that is the CAD model. What you need to do here, so as I have my CAD model as I indicate here, so I build my CAD model, and now I can display my CAD model. So I have two CAD models, which called air and water. If I display it here, this is water, so the water only. We have a pipe shape for the water, and the cross section is a rectangular cross section, right? So that's the water, and the air block, which will be the mean of the air inlet and air outlet. I can't see the cross section here, but the cross section means I don't have the water domain, so water is included in the air section. But that is my STL file for the two domains that I'm interested. And if you are interested, I can edit this. I would say all these files are in ASCII format, which means it all be readable, right? It can be all in text format. And now I export it as a meter unit. But if you accidentally export it as millimeter, you can use some command in the OpenFOAM to convert the unit from millimeter to meter by using the surface transform points scale 0.01, that is. But I have, so if you see the coordinate here, they are all in meters. I can see it's very small, so it's all in meters. what I only need to do is, as I indicate here, I need to copy the STL files to the constant and tri-surface folder. So I have a folder here, but it's completely empty except these two. But I can definitely build a folder called constant. So constant, and I build a sub folder called tri-surface. And what I need to do is copy. So remember, these files are exported from your CAD software, and I can copy it in here. So that is preparation of the CAD files for your operation.